previous video we have discussed the truss 2-bar truss element. Here we stopped till the application of boundary condition. As you can see here, to apply the boundary condition we should have the equilibrium equation, that is K into Q is equal to F, where K is stiffness matrix. Stiffness can be defined as load by displacement, so we can write K into Q, this K into Q is equal to F. Once we define this equilibrium equation, we need to substitute the global stiffness matrix, global displacement vector and global load vector. After substituting the values, next step is to apply the boundary condition. Usually in solving the problems of trusses, what we do, we usually use this elimination approach of handling boundary condition, because it is very easy to calculate and it is less time consuming, whereas penalty approach, it requires more time. And the thing is, here we get many set of equation to deal with those things, it requires lot time. So here in any of the truss problem, you can approach this elimination method. Here we'll see how to apply this elimination approach. If you see the problem here in this, what are the rows and columns we need to eliminate, we'll see now. Here, as we know that the node 1, this is node 1, this is node 2, and this is our node 3, right? So node 1, it is fixed from both the x direction and y direction, means u1 is fixed and u2 is fixed. Whereas this node 3, it is fixed from horizontal and vertical, means in x-axis it is free, means u5 is fixed and u6 also fixed, right? What about this node 2? See here, I will write this is node 2, for example. Here you can see this figure has rollers. Here you have roller support, in the sense this truss can move, this joint can move in either direction, in x direction, in the positive or negative, in the sense it can move in the x direction. But whereas vertical movement is restricted by this this joint. So here if you see, we have displacement in the x direction, which is we have displacement u3 and we don't have displacement u4. So what are the displacement fixed here? In the node 1 u1 is fixed and u2 is fixed, and in the node 2 we have u4 is fixed, and in the node 3 we know that v5 and u6 is fixed. So we need to eliminate these many rows and columns in the equilibrium equation. Now we'll see, here we have equilibrium equation. If you see, this is nothing but our first one, second row, third, fourth column, fifth column, sixth column. First row, second row, third row, fourth row, fifth row, sixth row, right? Here what we need to eliminate, we need to eliminate the first row, first column, similarly second row, second column, and we need to eliminate fifth row, fifth column, sixth row, sixth column, since these nodes are fixed. Again, there is no vertical what we call vertical movement in the second node. We need to eliminate fourth row, fourth column and fourth row. What is left here? 4.53 into 10 raised to 4 into u3, which is equal to minus 10,000 into 10 raised to 3. That's what we have written here. 4.53 into 10 raised to 4 u3, 4.3 into 10 raised to 4 into u3, which is equal to this one. So if you simplify this, you will get this answer. u3 is equal to minus 22.075 millimeter. Here it is minus in the sense it is acting in the negative x direction. Clear? The displacement in negative x direction. This is nothing but the nodal displacement. This matrix gives the nodal displacement. u1 is fixed, u2 is fixed, and u3 which we got, u4 is 0, u5 is 0, u6 is 0. So that's how we need to calculate the displacement. This is all about the problem which is given in the VTU question paper, which is December 2015-16. Apart from this, we can also calculate the stresses for this, as we know that stress can be calculated for this by using formula. Again, E by L, we have that formula, minus L minus M, L M, L, right? Here we have E by L, here we have minus L minus M, L M, and here we have u1, u2, u3, u4. By using this formula, we can also calculate the stresses for the each element. First element, here we need to substitute u1, u2, u3, u4. Second element, we need to substitute u2, u3, u4, u5, u6. And these direction questions we need to substitute for the each element. This is how we can calculate the stresses. Apart from this, we can also calculate the reactions. To calculate the reactions, we have formula R is equal to K global stiffness matrix and the global displacement vector minus global load vector. From this, we can calculate the reactions also. Here, usually we calculate the reaction at the supports. Means you will get a reaction load at node 1, 2, 5, 6 as well as here at 4. So 1 to 4, 5, 6, 1 to 4, 5, 6 you will get the reaction forces. In the node 3 you will get 0 reaction. You just calculate and comment below so that I can tell you whether it is correct or not. Thank you for watching. If you have any doubts, any queries related to trusses problem, you can comment below.